How do we tell if vectors are linearly independent? So recall that a collection of vectors v1 up to vp in Rn is called linearly independent if the vector equation x1 v1 plus up to xn vn equals 0 has only the trivial solution. So notice this vector equation star is homogeneous. And so it's always going to have the trivial solution, and it has non-trivial solutions if and only if the vector equation star has free variables. Now this is something that we can check using row reduction or Gaussian elimination. So that means we win, right? It becomes a fast, straightforward computation. So specifically, we row reduce the augmented matrix with columns v1 up to vn augmented with just the 0 vector and see whether or not the first n columns are pivot columns. If the first n columns are pivot columns, then x1 up to xn are basic variables and there's no free variables, so the set of vectors v1 up to vn is linearly independent. Otherwise, the set of vectors is dependent. Let's see how this works out in an example. So consider this set of vectors, and we want to compute whether or not this set is linearly independent. So we stack the vectors up together like this, and we do our Gaussian elimination. If we push up to reduced echelon form, we end up with this matrix here. I like to put squares around my pivots so that it's clear. And if you notice, this tells us that we have pivots in the first 3 columns, which tells us that there are no free variables because columns 1, 2, and 3 are pivot columns. So x1, x2, and x3 are basic variables. Note, we don't actually have to compute the reduced echelon form in order to see this. We could have stopped earlier at the echelon form and read off all the relevant information because all we need to know are which columns are pivot columns.